Hello everybody. In this video clip I want to show you quickly how we can calculate the margin of error and a confidence interval in Excel. Now let's assume three students, Tom, Wahid and Toya, are doing an experiment where they plate some E. coli cell on plates and then they count how many cells have grown on these plates. And they do that in triplicates, so each of these students uses 3 plates. And so Tom gets 19, 15 and 24 cells respectively on his plates. And of course he wants to know actually what is the average. And he finds that the average is about 19.33 cells per plate. I'm not entirely sure if we can interpret the 0.33 cells very well, because you can't have a third of a cell, but it's around 19.33 cells per plate. Now, Wahid comes along and does exactly the same experiment, counts his cells. He gets 22, 19 and 35. And he gets on average 25.33 cells per plate. So immediately there is a little dispute between Tom and Wahid. Who is right with their average? What is actually the real number of cells per plate? Now Toya does exactly the same experiment, and she gets 33, 29, 35 cells on her 3 plates with an average of 32.33. So she says, wait a moment guys, you all got it wrong, I've got 32.33. So who is right? Well, actually we don't know. Because in a way everybody is right, these are the results that they achieved. But what is really the true average? Well, what we would need to do is we would need to do this experiment several times. In fact, in order to get a really good understanding and accurate value of the average, we would have to do this experiment 100 times, 1,000 times, millions times, infinite times actually. Only then, when we do it infinite times, we will be able to say exactly what the average per plate is. But nobody wants to do that, of course. We have done we have 3 students here, and of course if 100 students did it, we would probably get 100 different averages. This is actually called the sampling error that we make. So that's the sampling error. Each student, of course, is right. They get their individual average here. Now, what we need to do is we need to say, right, we want to be fairly sure that our true mean for the cells per plate is somewhere around these numbers. We want to really know what is the true mean if we do this experiment infinite times, but we can't do it. So what we can say is, right, let's just simply look at the standard deviation, and here we would use a sample standard deviation, calculate the sample standard deviation. So Tom has a standard deviation of 4.51, Wahid has a standard deviation of 8.50, and Toya, she has standard deviation of 3.06. Now, in a way, the standard deviation doesn't help us because it tells us just simply what is the spread here. So what we can do is we can actually use what is called the margin of error. And the margin of error tells us basically where we would expect the true mean to be. Obviously, we would not be able to say exactly where the true mean is, but we could probably give a sort of a range. So the true mean for, if we did this experiment 1,000,000 times, the true mean would probably between, let's say, 0 cells and maybe 50 cells. That is where our true mean is when we did this experiment. And only if we did it 1,000,000 times, then we would say, right, the true mean is exactly 25.13 or something like that. So how do we get the margin of error? Now, the great thing is that in Excel, we have actually something that automatically can calculate this margin of error, and that is this equation here. So it is confidence T interval. So how do we deal with that? We just simply put in this equation equals confidence T, and if you start typing, it comes up with that. And now this confidence T asks us basically what do we want to have. Now for the alpha, very common is that we use 0.05. That would be a 95% confidence interval. So we want to be fairly sure that our true mean is within this interval that we have here. So what we need to do now is just put in our alpha, and we said that is 0.05. We need our standard deviation, so this one here, and we need the sample size. And we have 3 samples here, basically 3 plates that we use, so 3. And this now calculates our margin of error. So our margin of error is 11.2. And we can do that now for Wahid's and Toya's samples as well. I just drag it along and remove this. So the margin of error for Toya's plates is 7.59. For Wahid's plates is 21.13. So there is quite a bit of margin of error. But we can see that because he has quite a large spread here in the standard deviation. And Tom's results are sort of in the middle. So what we can do now with this margin of error is we can identify an interval in which we believe will be the true average for all the experiments that we can do. And in order to do that, what we do is we calculate the upper bound, and the upper bound is the average that we got plus the margin of error. So let me write this down here. So the upper bound is average, and that is our x bar plus the margin of error, and the lower bound, I should probably do it like that, the lower bound is the average minus the margin of error. So what we can do is here just simply we say for the upper bound we take the average equals the average plus the margin of error, and for the lower bound we take the average minus the margin of error. And we can do that for Wahid samples. Again, we say is the average we've calculated plus the margin of error. And here this is the average minus the margin of error. And we can do that for Toya as well. For Toya's sample, I just drag it across. And this one here as well, across. So what we now have are ranges. They are intervals. So this means from Tom's result, we can conclude that the true average for all the plates in the world done under these conditions would be somewhere between 8.13 and 30.53, with the average for Tom in the middle. So this here is our confidence interval. So that is the confidence interval. Confidence interval. Or in other words, we are fairly confident that our true average for all the plates is somewhere between 8 and 30 cells. For Wahid, we have a confidence interval, sometimes abbreviated as that, where we say, okay, it must be between 4.21 and 46.5. And for Toya, we say the true average must be between 24.7 and 39.9. And what we obviously observe here is that I forgot to write that down for Tom. So it is between 8.1 and 30.5. So what we can see here is that Tom's prediction would be that the true average is between 8.1 and 30.5. Wahid's prediction is between 4 and 46.5, and Toya's prediction are, so they are all in the same range. Yeah, and that makes this confidence interval quite a powerful thing, because it gives us a rough estimate where we would expect the true value for our experiment. So despite they are getting here the averages, with the confidence interval, it tells us where we can expect the true average for the results. So confidence interval is a very powerful tool that tells us not exactly what the population mean is, but it gives us a range in which we can be fairly confident that the true population mean, when we do this experiment a million, zillion, gazillion times, where the true mean for this experiment lies. So I hope this makes sense, and thank you very much for watching.